Right, good morning everyone. I can trust that you can see my screen. It's Mr. Corley again, and today we're going to be talking about the large data set. We've also got Miss Smith and Mrs. Owen and Miss Gritsuk and Mr. Pearson in the chat as well. There may be lots of questions today, there may not be that many. It depends on how much work you've done on the large data set already. But do ask your questions in the Q&A. It might be that some of them we don't have an answer for straight away. If that's the case, if there's any time left at the end of the lesson, which I am assuming there will be, I'll have a look at those and it'll be quite interactive at the end and we'll have a look at those questions together. I'm going to be talking about the large data set and some of its notable factors. It has a few things that are worth pointing out. Now, obviously, I can't teach you about the whole large data set. There are over 20,000 pieces of data in it. So no, you're not expected to learn it all. That's obvious. But you are expected to know the trends and patterns, and as I said, some of the notable factors during it. So a few things before we start looking at it. So this is taken from the AQA website and just describes a bit about what the large data set is. Obviously it is going to be for your exam and there will be some specimen materials, but there aren't that many at the moment. But those bullet points are particularly things that you need to be aware of. You need to understand the categories and subcategories that the large data set uses. That's really base level. You need to go in, you can't look at data and not know what the categories represent. Now, I'll just say here at this stage as well, the reason that this is in the A level is because actually it's quite a realistic thing. As part of your job, as part of my job, I have to look at data. I have to be able to work with it and analyze it and figure out what's going on and see trends and look for outliers. So this is quite a realistic thing that you can get given a lot of data and you have to try and interpret it. And that's what's key. And this is why this is part of the A level. I will say it's only a small part of the A level. But that being said, understanding the large data set could be the difference between a grade. We know how it works. 1 mark, you get a B, 1 more mark, you can get an A, or whatever grade boundary you're looking at. So where it's a small part of the A level and therefore it's not really worth getting overly hung up on, it's still important enough that this could be the difference between a grade. So as I said, you need to understand the categories and subcategories. You also need to understand how the values work within the large data set, and that includes the rounding. You need to have knowledge of the trends within the data. That could be correlations, that could be certain averages. There are lots of things to look at there. And you also need to be aware of some outliers and anomalies, and that's a really important part. It's really important that when you are looking at data that you can spot an anomaly and determine whether it's an outlier or whether it's a mistake or whether it's genuine data that's just happened to be quite rare. So all of these things you need to be taken into account. This is literally taken from the large data set. I've just taken it like this because I've put certain things in bold because I want to emphasize certain things. Firstly, the make of the cars. We know it's a data set about cars. There are only 5 makes of cars. And we'll look at what they are. You should have an awareness of that anyway. The cars are either from 2002 or 2016. So 14 years difference between the age ranges of the car. And because of that, that means you're looking at different time periods. You might have to think why there might be differences in those 14 years. We know technology is constantly advancing. So you've got to be analysing, well, what difference is that going to make? The government region, I don't know how important this is particularly, but the registered keeper of the vehicle lives in London, the Northwest or the Southwest. One thing to be aware of, and you might have heard this, especially with reference to the previous large data set, which you don't need to know anything about, but London is often an anomaly. London is different because there are less family homes, there are more businessmen, there are more taxis and public transport. There are less people who own a car in London than there would be in a town or city in the Northwest, for example, Manchester, or in the Southwest, for example, Bristol. So these are all big cities, but have big differences in the way that they work. And London often is a bit of an anomaly. Also note the category type. They are all M1 vehicles. In other words, they are all cars. There's no more than 8 seats per vehicle. You don't need to worry about other kinds of vehicles such as vans, lorries, buses. They are all cars in this large data set, even if some of them are big cars. All this information is on the large data set, which you should have already accessed. You should have already looked at. So here are some of the key fields. I'm not going to read through them all because some things have already been covered, but I am just going to emphasize certain things. So the mass of the vehicle, and it says the mass of the vehicle is in kilograms, and it's really important that you are aware of the units given. And that includes the mass of an average driver, and they've said an average driver is 75 kilograms. So all the masses should be X, the size of the vehicle plus 75, and that is taken into account. Other things to be aware of are units. So if you look at all of the emissions units, we're working in grams per kilometre, and you need to have that awareness of what each part is measured in. There are different types of emissions. You've got carbon dioxide, carbon monoxide, nitrous oxide. It just refers to particulate emissions and hydrocarbon emissions, but you have to know those units particularly. Be careful there because the mass of the car is in kilograms, whereas the emissions are in grams per kilometre. This is also part of the large data set, and there's a few other things just to be aware of. It's just an extended column, but not all data is there for all cars. So you can see clearly there that certain pieces of information are known for 83% of the cars for CO2, and it decreases that a little bit. And then particularly in the particulates, that's only known for 24%, I believe it says. It's slightly hidden on my screen. And then the hydrocarbon is for 51%. Also note that the particulate emissions are only for diesel vehicles. And I say that now because that'll have some importance. So now we're actually going to flick to the large data set, and I can trust that now you can see that screen, the screen that we've just been looking at, but now we're actually in the large data set. We're going to look at the field values just to be aware of some of the things referred to. Firstly, propulsion type, how the car is powered and how it moves, will either be petrol, diesel, electric, or a hybrid of gas and petrol, or electric and petrol. And you need to have that awareness of what the codes represent. Now it's only, you can see across the page, it's only, it's less than 20 codes to know, and I don't think you'd be tested on what does 1 represent, what does 2 represent, but it's worth having that awareness. Especially in terms of the different types of cars. You've got 2-door saloon, 4-door saloon, general saloon, which seems quite strange. A convertible car, a coupe, estate, 3-door hatchback, 5-door hatchback, or multi-purpose vehicle. And going into a bit more detail, by looking at the data, you'll figure out what a multi-purpose vehicle is. That is something that might also transport something as well. It might be one of your 8-seater cars. And then I don't know how they could possibly use this information to keep the title ID. They could look at male and female and look at the differences there. I'm not sure how they could get into it that a reverend owns a car or a doctor owns a car, but you don't know. But a company vehicle might be something to note. A company vehicle might be used less than a household car. It's trying to analyze the data. We don't know a lot about it, but we're trying to use the data to figure things out. Sometimes we might have to extrapolate a little bit. We might have to try and figure out and relate it to real life using your knowledge. But it will all, if that was the case, it would have to be something general knowledge. So that's in the field values. We've looked at the definition of the fields. We've looked at the introduction. So now we're going to get into the car data itself. And I've highlighted certain things. You don't have this highlighted. You have to highlight it yourself. And what I did was I just took each column and I've sorted each column. So I could sort it smallest to largest. I am going to zoom in just a little bit. Hopefully it is clear enough on your screens. And you see there's these references of cars. They're listed. I don't know what the order is. It doesn't say in the summary given, but I do know that with this data, it does have a reference number. If you think about it, that could relate to sampling. If you think about the different sampling methods, we know that if it's in an order already, that we could, for example, take a cluster sample and we could randomly generate a value originally and then take a cluster from that value. Or we could just do a random sample using a random number generator, get our sample from the reference numbers. That would be an option as well. While we're talking about random sampling, there is also this random number column. And note this, if I change any of the data or sort any of the data or just do something to it, if you look at the numbers at the top, all I'm going to do is resort it and that random number changes. None of the other data is changing because I'm just sorting it by the same value. But anytime I do something, it generates a random number. And that could be useful as a random number generator, because this way we could order it by random number, which again, it would change as soon as I do this. But what that means is now the data has been put into a completely random order. So rather than having to generate lots of different random values, if you think about what we do when we randomly generate, we need our sample size, we need to generate however many unique numbers. I know you've done it on your calculators with a random number generator. You could do it like that. But you have that's a long process. Here, I've just ordered it by random number. So I could now take the first 20 and there I've got a sample of 20. So just things to be aware of. You can see even just I've put a filter on the top. I mean, I'm not here to explain how to use Excel, but just on the top row, if you click on sort and filter, you can click on filter and it'll come up. You can see by clicking on these filters the different makes that are there, things that we have already briefly looked at. The different makes there: BMW, Ford, Toyota, Vauxhall or Volkswagen. So we've got the 5 different makes there. We've got the 5 different propulsion IDs that we've already talked about. Remember 1, 2 and 3 were, what was 7 and 8? 7 and 8 were your hybrid cars. We've got the different body types there. We've got the different regions. These are all things we're expecting. Different keeper title IDs. So we could have a look. We could go back to our field values, see that I'm going to focus on that reverend and doctor, etc., because I find that interesting. So there I can see that these cars were kept by reverends, doctors, you know, whatever those other titles were. All right, now we're going to get into some of the more interesting things within the data. And this is where we need to start looking for anomalies. So if I look at the engine size, and currently it's just sorted randomly, but I can see by looking at the filters that I've got some really big engines down here. I can't remember what they were measured in, so I can just refer back to my definition of fields. Engine size measured in cubic centimeters. So I can see here the biggest type is 4,951 cubic centimeters, but the smallest engine is 0. And let's have a look at those cars. There is one car with 0 engine size. And you should be thinking here, it's one of two options. It's either an accurate value, but it's weird, or it's an inaccurate value, which we call an anomaly. So let's look into it a bit more. If it's got an engine size, why might it have 0 engine size? Well, the propulsion type is number 3. What was that? Well, it's an electric car. That might refer to why it has 0 engine size, because an electric car is not going to need an engine in the same way. It's powered by battery. So things to think about there. That is something worth highlighting, something worth noting. I'm going to keep going with this. Mass. Now, again, remember what we talked about with mass. We've got some big masses down here. These are the heaviest cars. And you might want to look at how mass correlates with emissions, or how it relates to even gender or the year of the car. It might be worth looking at those. But the key anomaly I've noticed is this one, 0. And this is where I'm thinking, on the last one, I'm trying to figure out, is it an anomaly or is it accurate? For this one, I know that even if the car weighed nothing, the average human being, unless it's a driverless car, which I'm pretty sure didn't exist in 2002 or 2016, so there should be at least 75 kilograms plus the car. Yet we've got all of these with 0. Well, why might that be? For me, my guess is it's an anomaly. Now, there seem to be a lot. I am just going to order it by mass here just to see exactly how many. So I can see here, start on number 2 because of the top row. So there are 92 cars with 0 mass. Now, we're here trying to interpret the data. And my assumption is that that is a mistake. It seems that they're all from 2002. So it might be that they didn't have the data. But if you don't have the data, you can't just put in 0. So you've got to think about the data. You've got to try and be critical. Again, if you got given this as part of your job, you'd have to be critical. You have to make those decisions about whether it's an anomaly or whether it's just a rarity. Moving on from this, I'm going to look at CO2. And again, I'm just going to sort it by colour because I've already sorted a few things. There's 2 cars here which have 0 CO2 emissions. If we look at the propulsion type, we've got a 1 and a 3. One's petrol, one's electric. It might be that they're both completely accurate, but in 2002, the idea that a petrol car emits 0 CO2 emissions, well, that to me seems like a mistake. On a number 3 car, an electric car, I don't know much about electric cars personally, but actually maybe they don't give off CO2, and we've got no data for CO or NOx, so maybe that is accurate. You can do more research into types of cars, but it shouldn't give you a specific advantage. These are all expected to be general knowledge or stuff we can assume about cars. So looking at those 2 values there, you might even be told one of them's accurate, one of them's a mistake, and you might have to determine which one the mistake is. Just to emphasize as well that they might give you a certain section of the large data set, like a screenshot. They might give you that during your exam. They might give you that to help you out. Again, I'm just onto this last column now. particulates, and again, I'm just going to sort by the colour. In fact, I'm going to filter by the colour, so all we've got is the yellow ones. Now, the reason I've highlighted this one is just because of something that we talked about briefly before. It's said in this definition of fields for particulate emissions only for diesel vehicles, 24% of the cars in the whole database. Well, diesel vehicles are number 2. But what I can see straight away is that I'm left with some ones. This Toyota is a petrol car. It has particulates, and it said that they only had them for diesel cars. So maybe that's a mistake in the data. Through all of this, we're trying to be critical. We're trying to analyze, are there mistakes in the data? And having an awareness of the fields and what those values are can really be useful to answering the questions. We're going to look at a couple of extra trends which my further maths class did some research for me, and I've taken some stuff from them. So going back to the PowerPoint, we're just going to look at a few trends, and I will mention them because these are taken from my further maths class, so they have done the work for me here, which I massively appreciate. And here we can see just a few trends. We can see a nice bar chart. It's not the best bar chart in the world, but it's nice and colourful. It's clear as to what these things are. There seem to be 2 reds, which is confusing, and 2 blues, which isn't ideal, but that's not what we're looking at. We're looking at the values, and there's no point just looking at one year unless we're looking at the different types. But here I'm just going to look at this year in 2002 versus 2016, and you can see that particularly for the 5-door hatchback, which is the second blue column, the largest blue column, it has increased dramatically. Some have gone down. The 3-door hatchback has gone down. The estate has doubled. Obviously, this is a sample. We can't necessarily just apply it to all cars, but we can see there has definitely been a dramatic increase in the 5-door hatchback. Just one thing to look at there. Here are some scatter graphs, and we can see that there are some things that are maybe skewing the data. These values on the left-hand side, on the y-axis, which unfortunately there's no key for, so I can't exactly tell you what's going on, but we can see that there is some correlation. We can see that, especially if those were anomalies or outliers on the y-axis. If we could draw our line of best fit through, well, there is definite positive correlation in this scatter diagram. Whereas here, if we look at the yellow one, there appears to be virtually no correlation. I can't draw a line of best fit through that. I can't see the trend. Interestingly, on the blue one, I can see it's almost split into 2. Why might that be? Are they from different years? Is it based on something else? But again, there isn't much correlation there. It's maybe slightly positive, but if it is, it's minimal. And then looking at the green one, again, very little, very weak correlation, but maybe slightly positive. And this, again, is something you can do. Now, this is looking at mass and emissions. I've looked at the title now. It doesn't say which way around, but I'm assuming from my knowledge of the large data set that the mass is the x-axis and the emissions is the y-axis. So I could say, looking at the orangey graph, there appears to be a positive correlation between mass and carbon dioxide emissions. There appears to be, however, no correlation between mass and carbon monoxide emissions. So by using the spreadsheet, you can find out this data too. Here are some more, just some nice graphs to really see the trends. This is looking at engine size and emissions, again, things that might be related. And we can see on the orange graph between engine size and carbon dioxide emissions, there is a very definite positive trend. Now we don't know the value, we could guess the value. All I can say for sure is that it's a positive correlation. With carbon monoxide this time, there appears to be a positive correlation this time, but it's a lot weaker than the carbon dioxide example. And again, we can see on the nitrous oxide one, there is not much of a correlation. You can't see a very obvious trend in that. Whereas with particulates, maybe there is again a slight positive correlation. Here is a histogram just to show carbon dioxide emissions between cars in different years. And what we can see is the purple is to the left of the red in simple terms. It's a fairly obvious example that the CO2 emissions were less in 2016 than they were in 2002. And you might just want to think why that might be. And then just as we bring this to a bit of a close, here is an example question. It's a practice paper question. The bar chart shows the distribution of the body types of cars as represented in the large data set. The data represents all 1,299 cars in the large data set, which were registered in 2002. It's given us quite specific values. It says Freya has correctly identified the median numerical value from the bar chart as 14. That's the information we have. And the questions they could ask. So state the body type corresponding to the numerical value of 14. I'll just give you a little bit of time to think on that. The question, give one reason why Freya's median has no validity. And thirdly, state one valid statistical measure for the data shown in the bar chart. Not the easiest, not the most simple worded questions, but from your knowledge of the large data set, you should have some idea of what's going on. The body type corresponding to the numerical value. Well, what was coming out as the most popular car type? You are expected to have an awareness of this. And that would be that you correctly identify a 5-door hatchback. So that is the most common type there, because it's the highest value. It's also the median which we're told she correctly identified. But why has her median got no validity? If she chose 14 as the median, why does that have no validity? Well, you're expected to understand that the numbers represented are simply codes that are just given to refer to the body type. They don't have any mathematical meaning. They don't have, if you look at the example, the way it said there, the original data is categorical. So in other words, it has no structure to it. Data. In other words, the intervals in between don't mean anything. So the values given have no validity. You can put that much more simply. You could say the numbers just represent a car type. They don't have any mathematical meaning, so they are not valid. That would be simple enough. And lastly, state one measure, one statistical measure of the data shown that would be valid. Well, I've alluded to it. I've mentioned it already that the 14 was the most common type. I can look at this data and say, all right, I don't know the average. I can't put a number on that because it's categorical. I can't have a median again because it's categorical, but I do have a mode, and the 14 is the mode that the 5-door hatchback is the most common type. And again, just one more graph, a rubbish graph. just to show you that actually with categorical data, we're not going to get rich results. And again, that's because the differences between 1 and 2, 2 and 3, 3 and 4 don't mean anything. If you look at the values given, we could have put 1 to 95. Well, that scatter graph isn't going to represent anything. It doesn't show anything, and that's why we end up just with these lines of data. So be aware of that when you're going through it. That is the end of the structured part. I am just going to leave this on just on this screen just for you to refer to. I'm not sure if there have been any questions, but I am just going to look at the chat that is going on and just have a look at some of the questions. I'm not sure if any of my colleagues have noted any questions that they want me to look at. I can see one here. I'm confused. What does this mean for our exams? How will it be used? Again, yeah, difficult question to answer. They could just give you an excerpt from the data set and get you to use something within that. I'll show you an example of that actually. They will draw on your knowledge of it. It's fair to say they will absolutely test that you have some understanding of the large data set. But just see if I can find this question for you. But what I can also say is that you're not expected to know all of it. You are expected to know trends. I'm just producing a question here. I'll share this with you. So this is another example question. Hopefully you can see that on the screen. They could give you an excerpt from the data set, and that would be something that you would then have to refer to. But as you can see from the questions that I've shown, they could ask you questions just simply testing, do you have an understanding of what is going on? Do you know what the values mean? As next year progresses and you do a practice paper and more practice questions come out, it'll all tie together that bit more. So again, as I said before, I don't want anyone to get hung up on the large data set. It's a small part, but it will be covered more next year as well. Just seeing if there are any more questions here. Would we get the tables in the exam with the different codes? Probably not, because they might test you on what the codes represent. But they might ask you what, like in that question, what does 14 mean? In which you'd be expected to say that's 5-door hatchback. You're expected to have that knowledge, but I don't think you'd be expected to remember all the ins and outs of the codes. Should we memorize key facts, e.g. the mode for the cars from the data set? Yeah, that would be a good thing to do. As I said, this has all been about looking at trends and notable factors. So yeah, definitely knowing some of the key trends, the key facts about the large data set, definitely the things you should be revising. I can see one question just saying that they're a bit confused, especially I'm talking about it like you all know what I'm talking about. Your teacher will have set some work on it on the large data set, your statistics teacher. And if you're not sure, you need to email them and get in touch with them. If you haven't been able to access it, you need to speak to your teacher about that. But the large data set is available for you. There has been work set on it. So get in touch with your teacher, ask them about it. Also, I'll keep emphasizing this, I've said it to my class this week as well. Use the VLE to ask questions if you're not sure as well, because it's not being used as much as we'd like, and that's your best source. We've got members of staff monitoring the VLE for 4 hours a day. You might as well use it. You might as well ask your questions. There's absolutely no shame in asking questions. And in fact, the people that have been asking questions will have definitely got the most out of it. A question there, how many marks will this be? And I can see Miss Smith has answered it. The honest answer is it's not going to be loads and loads. But as I said before, it could just be like in that question, 3 marks. And those 3 marks could be the difference between a C and a B, or a B and an A, or an A and an A star, or whatever grade you're looking at. So it's certainly worth putting in the time, especially over the summer, just having another look at different trends going on. And again, speak to each other about this. If one of you have found something interesting on the large data set, talk to each other about it. Ask someone else if they've found it. And you can ask your teacher as well and just check that they agree with your findings as well. Very rarely will you look at data by yourself. You can look at it with other people just to check that people are agreeing with your interpretation of the data. I can't see any more questions. I'm just going to have one last look on the new ones that have been put in. How long will we spend on this in school is one last question. It will keep coming back to it. It'll keep being referred to. But while you've got the time now and over the summer, have a look at it. Look at some trends. Look at the work that has been set on it. And use that just to try and explore what's going on this 20,000 item piece of research. Because at some point in your life, when you've started your degree or when you're working, you might just be lumped with a load of data, and you might get asked, right, we need to find out certain things about it, and you might have to interpret it. So yes, spend time on it, but you will look at it again in year 13. And especially when you think about the amount of time that we'll have before the exam, you'll do practice papers, you'll do revision, and all of this will be reiterated then as well. I can't see any more questions coming in, so I am going to leave it there. If you do have other questions, use the VLE to ask. And if you haven't accessed the large data set yet, get in touch with your teacher and they will guide you to it. This will be recorded as well, so if you want to refer back to it, it'll be on the VLE, hopefully from tomorrow. All right, thanks everyone. Bye.